Hi, this is Ben Osborne with Thermo Scientific, and this video is on creating a simple workflow in Proteome Discover 1.4. So first you need to open up Proteome Discover 1.4, and from any menu you can reach the workflow editor here, and I would select New Workflow. Now, every Proteome Discover workflow has four essential components. The first one is that you load some Spectrum files. The second one is that you look within those Spectrum files and you decide which spectra to actually use. And the third is a search engine, and in this case I'm going to use the new high throughput sequest. And the final essential component is a false discovery rate calculator. In this case, I am going to use Percolator. Now, there's a logical double check here in the workflow editor. If I can draw an arrow from one node to another, then Proteome Discover says that this is a logical progression for our workflow. I cannot, for example, go directly from Spectrum files to sequest. Because I cannot draw that line, this is not a logical progression, and it gives you a quick double check that you are making a workflow that will produce results. And so I would go from my Spectrum files to my selector to sequest to the false discovery rate calculator, and this is the simplest workflow that you can use in Proteome Discover. From the Spectrum files, you'll notice that the right window here changes according to what node that I have activated. In this case, we go to Spectrum files, I get file names, and by clicking on this, I get this little ellipsis, and which clicking on will give me this Add Files window where I can add a file. I click Open, I get the file. Now, if I am at this point going to open multiple files in Proteome Discover, say for example, I go to add this HeLa as well. Now I have these two files. It is going to assume that these are fractions from the same experiment. It is going to mudpit these data files together. I know that these didn't come from the same place, so I do not want to mudpit them together here. So once you've selected the raw file or raw files that you want to use, you can go to the Spectrum selector and decide what filters to use. And the defaults here are really nice, and a lot of times it is unnecessary to change these. You know, you're looking from a mass of 350 to 5,000. You're just in general not doing a lot of filtering here. Anything extra you add here is simplifying the job of the search engine. So if I want to say, for example, that I'm only interested in MS spectra that have a minimum of 10 peaks in there, I will add that here and say I'm only interested in precursors with a mass of 700 to 5,000, and I only want to see peaks with a signal noise threshold of at least 3. This will filter out some bad spectra and give sequest a little less to do, so it will work a good bit faster. Simplifies its job and simplifies the downstream processing. I go to sequest. Here I can open any FASTA database that I have imported into Proteome Discover. These are all available here, and I will just pull up my human uniprot and add that. Now I can also pull in any enzymes that are currently accessible by Proteome Discover. All these can be added. I can set my precursor mass tolerances. In the case of, say, a hybrid experiment, this is generally the defaults I would use, where my MS1 mass tolerance is at 10 ppm and my fragment mass tolerance for the ion trap is at 0.6 Daltons. The weighting here for A, B, and Y ions is set up for the default, assuming that we are looking at CI defragmentation or even HC defragmentation, will yield predominantly B and Y ions. If I was using ETD, I might change this weighting to 0 and 0 for B and Y, and give a weighting of 1 for C and Z. Under dynamic modifications, here you're defaulting to a maximum of 3. If you're using a labeling technology such as Silac, which is already going to add at least 1 modification onto your peptide, you might want to raise these minimum number of dynamic mods, but keeping them at 3 lowers the amount of work that seaQuest has to do, so it makes things a little bit easier. The dynamic modifications, I can access anything that is checkmarked in my chemical modifications menu, and for more information on that you can refer to the Getting Started with the Administrations tab video. And I can select any of these modifications and I can put it on whatever peptides I believe that they might occur on. Same thing for static modifications. You get those same mods, except you are assuming that that modification occurs at every possible point and on every single peptide. This makes the job a lot easier for seaQuest, but it's one of those things you only want to use if you are 100% sure that that modification is occurring 100% of the time. And under our false discovery rate calculator, you don't have a lot of options here. For the percolator, these are the preferred parameters, and if we were using something else, say our target decoy false discovery rate calculator, we're going to be using a 0.01% strict false discovery rate and a 0.05 for our relaxed false discovery rate. If you wanted to add in, say, additional search engines, in this case I have Mascot configured, so I can very easily put Mascot in here and draw some arrows. So now I will get a compiled report from this raw. If I were to run this, I would get this raw file filtered through these spectrum selector criteria, and the resulting MS-MS spectra ran through seaQuest, HT, and Mascot, ran through this false discovery rate calculator, and compiled into a single report. In order to clean up this workflow and make it a little more pretty, you can just auto layout. I can also auto number them so that they're numbered in order, and we can add in any number of nodes here, but we're going to go into more complicated workflows in later videos, but this is just a start on how to get started with the simplest possible workflow. Okay. And we'll talk more later.